So today our aim is going to be how do we solve a system of equations by graphing them. So we learned everything about lines, so we know how to graph lines. So the first thing I want you to do as a do now is you're going to graph each of these lines on the graph provided over here. So take a minute, pause this video, and do that. So if I look here, we have graphed both of the equations. So we used our y-intercept, plotted that, and then used our slope in order to get the first line. And then the second line, we plotted the y-intercept, and then used our slope to get the other points on the line. So then the do now question said, where do the lines intersect? So we need to look here, and I see right here is where the lines intersect, and that's at the point -1, -1. So a system of equations is exactly what you see there. It's two lines, and the solution to a system of equations is where the lines intersect. So our system of equations are these two, and then the solution would be -1, -1, because that is where they intersect.
So when we're solving a system of equation, there are three different types of solution that we can get. The first example is just like the one that we saw there. They intersected at one point, so that means that there is one solution. So I'm going to draw just a little sketch of what that could look like. So there are two lines, and they intersect at that point, and that point is going to be our solution. So one solution is where they intersect at a point. Then we're going to have no solution. Now, brainstorm no solution. If they intersect at one point and that's the solution, no solution would be if they never intersect. So no solution is going to be lines that never intersect. And lines that never intersect we call parallel lines. I'm going to draw a little sketch of parallel lines. They'll go on forever and they will never touch. And finally, we have infinite solutions. So infinite solutions are always touching. So they have all the same points, which actually means that it's just the same line. It's one on top of the other. So just the same exact line, one on top of the other. So those are the three examples that we can have. So we saw one solution on the do now. Let's see if we could find out what example one is. Is it one solution, no solution, or infinite solutions? So let's take a look here. So I have my first equation, y equals -1/2 x plus 4, and my second equation, y equals 1/2 x minus 6. So the first one, my slope is -1/2, and my y-intercept is 4. So I'm going to graph that. So that tells me I'm going to go up to 4, and then a -1 tells me I'm going down 1, and my +2 tells me I'm going right 2. And if I went the other way, I would go up 1 and left 2. And we always want to draw our line with our arrows at the end. And it's now especially important that we're labeling it because we're going to have more than one line on the graph at once. So then for the second one, my slope is -1/2, and my y-intercept is -6. So that tells me I'm going down 1 and right 2 from my y-intercept of -6. So if we look at these two lines, what do you notice? These lines are never going to intersect, so that would mean that they have no solution. Lines that never intersect have no solution. So let's take a look at example 2. So example 2, my first equation is y equals 3x plus 1. So my slope is 3 over 1. My y-intercept is 1. So I'm going to plot my y-intercept. A positive 3 tells me I'm going up, and a positive 1 tells me I'm going right. So I'm going to go up 3, right 1. Or if I went the other direction, I would need to go down and left. So then the next equation, my slope is 3 over 1. My y-intercept is 1. So I'm going to plot my y-intercept, and then it tells me I need to go up and to the right. So I'm going to up 3. And if I went the opposite way, I need to go down and to the left. And what do you notice here? It's the same exact line. So if it's the same exact line, that means it has infinite solutions. And you could have figured that out just by looking at the equations, because the equations are the same. So let's do one last example together before I have you practice on your own. So if we look, we have y equals negative 2x plus 1. So my slope is negative 2 over 1, and my y-intercept is 1. So first I'll plot my y-intercept of 1, and then negative 2 tells me I'm going down, positive 1 tells me I'm going to the right. So we go down 2 and right 1. Then if it wanted me to go in the other direction, I would do the opposite. So I would go up 2 and left 1. So then we're going to graph the next equation. We have y equals 2x minus 3. So my slope is 2 over 1. My y-intercept is negative 3. So I'm going to go plot my negative 3. And then 2 over 1 tells me I'm going up 2 and then to the right 1. So I'm going to go up 2 and to the right 1. Then if I went in the other direction, I would need to do the opposite. So I would need to go down 2 and to the left 1. So then if I'm looking here, I see that my lines intersect there. So they intersect at a point. So that means that I have one solution. And my solution would be the point 1, negative 1. So if you have any questions, please make sure to comment on the video and I will be happy to answer any of these for you.
So now I want you to pause this video and try examples 4 and 5 on your own, and then I'll put up the answers for you to check. Okay, so for example 4, I apologize, I made a little error there with my graphing, but everybody makes mistakes. And there was also an error in the question because you notice they do intersect, but not at the same point. So while there is one solution, we don't know the exact solution. We know it's going to be some decimal in between. So if we look at number 5, when we graph these two lines, we notice that there is also one solution because they intersect once. This one was worked out nicely, and they intersected at the point 0, negative 4. So that is my solution to this system. So if you look at example 6, you notice that they intersect one time as well. So that means that they have one solution. And once again, they do not intersect at the same point. So that means you're going to get a decimal answer.
Looking at example 7, the first line was easy to graph. But if you look at the second line, it's not in slope-intercept form. So you need to make it in slope-intercept form by getting the y by itself. So you subtract the 4 on both sides. You end up with y equals x minus 4. Now, before even graphing, look at the two equations. They're the same exact equation. So what kind of solution does that tell you you're going to have? That tells you you're going to have infinite solutions because it's the same exact line.
So if you look at example 8, when you graph these, once again, they intersect one time, so you get one solution. And your solution there is a nice point at 1, negative 1. Then example 9, you graph them. They intersect one time. That point there where they intersect is a nice point, and that's your solution at negative 1, 4. Once again, if you have any questions, please comment on the video, and I will be happy to answer.
So I apologize. Any sound effects that you might have heard in the background of this video was Captain chewing his bone or playing with his toy.